So obviously there's a lot of systems in place on board the International Space Station to make sure we have a safe and livable environment for the astronauts and cosmonauts on board. Here to tell me about one of the new systems that's just been coming online in the past few weeks is Dr. Paul Mudgett. He's in the Environmental Sciences Division here at the Johnson Space Center. And Paul, first off, thanks for joining me here today. Now this new system, it's called the multi-gas monitor. Real quick, what does it do?
Correct. The multi-gas monitor is a laser spectroscopy-based device to measure four gases.
Mm-hmm.
Four gases are oxygen, carbon dioxide, ammonia, and water vapor. And the way it works is different gases absorb light in different frequencies. In fact, there's a fingerprint. We call it fingerprint. For example, there's a fingerprint for O2, a different one for CO2, a really complex one for water vapor, and a different one for ammonia. And they're all mixed together in addition to other gases in the atmosphere. So the trick is to pick a feature, a spectral feature, where CO2 absorbs and nothing else. So you can be very confident, and the device can be very selective to measure the gases, give you the right answers, not give you false positives. And we quantitate. Obviously, we measure the concentrations of each of those four gases. And we partnered with two small companies, Vista Photonics in Santa Fe, New Mexico. They're the expert spectroscopists. They figured out how to do this, and they developed it through the Small Business Innovation Research Program. We invested lots of money over the last 10 years in this technology. So we took advantage of it. We foresaw a need and design, help them design the system.
Okay, and you said you kind of foresaw a need. What was kind of the driving force behind developing this new monitor?
There's several motivations. One, currently we're using commercial technologies. Electrochemical has weaknesses. We have to supply that the devices much more often than we'd like to space station. We have a box or a device for carbon dioxide, another one for oxygen. We have another one for combustion products. And the idea that the big picture goal, and this is the first step, the big picture goal is like a Star Trek tricorder, right? To be able to measure all the gases you want in one device. And laser spectroscopy, I think, is going to take us there. This is the first step. This is four-gas monitor. We envision maybe another one for combustion products, or eventually combining all gases that we want to know in the environment in one unit.
Okay, so you're just kind of building and expanding constantly, and it's been running for a couple of weeks now. How's everything been going?
This is a technology demonstration. It's a flight experiment. And the idea is to let it run long-term, 6 months at least, on orbit. And on orbit's a different environment. Like, for example, in this room, it's much more complex in terms of the chemicals that are in it. And plus, you have maybe micro vibrations and whatnot that could affect a device. But it's been running great. We were very pleased with its performance. We're comparing it with other assets. We're comparing oxygen and carbon dioxide measurements with the major constituent analyzer, and they match very well. Part of the demonstration is to take it out of the rack. It's currently in the Japanese experiment module, and we'll be taking it out of that. The crew will be taking it out of that and then relocating it to several locations, leaving it a week in each location, then returning it to the rack to download all the data.
Okay, and so what kind of makes it different than what's already monitoring on board the International Space Station?
Our device is smaller, it's lighter, it draws less power.
And we have this one real quick, the one that we're showing. That one's here inside the room right now, just kind of giving us what our atmosphere is here inside of Mission Control.
Right, it's a fairly simple looking device, at least from the outside. It just draws air in with a simple fan. It flows across the optical cell. The cell is such that there's no alignments, no mirrors, no lenses, nothing that could get out of alignment from vibration or from bumping it. So it's very rugged technology.
Okay, well, what are some of kind of looking towards the future? You said you want to expand upon it and add in more gases. What are some of the future applications for this device, say on space flights to Mars, long duration, things like that?
Yeah, so for Orion, you need very reliable systems. Anything beyond low Earth orbit has to be incredibly reliable.
Yep.
And that's one of the goals of this tech demo, is to demonstrate that it doesn't need calibration, it stays in calibration, doesn't drift. Those are all the kind of problems we've had before with previous technologies. As I said, we want to combine gases. We want to be able to shrink it. This is not the limit to the miniaturization we can do. So we're excited about it. We think it is the future. So beyond spacecraft, the Navy, the submarines are a great analogy to the spacecraft. So they have
there's some
of the
applications down here on Earth too.
Correct, and under the sea. Yeah. So, and then mining. Anywhere that is enclosed space, you need to know buildup of hazardous gases. You know if it's a breathable atmosphere. Early morning kind of detection. And there are applications. I think everyone eventually will benefit from laser spectroscopy. It's just a matter of time. So.
Okay. Well, again, Dr. Paul Mudgett, the Environmental Sciences branch here at the Johnson Space Center, talking to us about the multi-gas monitor. Thanks for checking in real quick and letting us know, how you guys are keeping the crew safe. Really appreciate your time. Thank you.
Sure. Thank you, Dan. Glad to be here.